Pluto made them travel around the circle of Pluto, crossing the circle of another planet. Pluto, a confusing little planet outside our close group of planets, develops energy on the planet of cosmology. Continued reports point to an imaginable experience with Neptune, causing concern among scientists and space enthusiasts. Prominent figures such as Neil deGrasse Tyson and Michio Kaku have warned of the consequences of this endless possibility. But how did Pluto end up colliding with a neighboring planet? And what could this celestial conflict mean for life on Earth? Join us to find out how something huge just hit Neptune and how scientists are strained by this massive irregularity. Once considered an undisputed planet, Pluto's status changed and it was renamed a dwarf planet due to its unusual circle. Despite this humiliation, Pluto fascinates and intrigues the cosmic place. Subsequent predictions by respected scientists such as Neil deGrasse Tyson and Michio Kaku have raised concerns that Pluto's course may approach Neptune, suggesting an imminent series of collisions between the two divine bodies that could have critical effects on Earth. Pluto's excursion around the Sun stands out for its extraordinary qualities in our close group of planets. Its circle is particularly wide, exceeding an astonishing number of astronomical units. Since its appearance in 1930, Pluto has yet to complete a complete revolution around the Sun. Its personality is enhanced by the deeply elongated state of this circle, a deviation from rounds followed by significant planets. Moreover, Pluto's orbit deviates from the plane of the ecliptic by 17 degrees, giving its path a more extreme degree that distinguishes it from the other planets. The combination of Pluto's nature and its curved circle creates complex layers in its orbit. One prominent angle is its coincident approach to Neptune's circle. For about 20 years in each circle, Pluto ventured closer to the Sun than Neptune, defying expectations given their different positions in a close group of planets. Looking deeper into Pluto's circle, it is fascinating to note that it is not a wonderful circle, but rather an elongated circle that is more like an oval shape. This significant circle causes critical variations in Pluto's departure from the Sun during its journey. At closest approach, Pluto passes at a distance of about 30 Australian dollars from the Sun, while at its furthest point it is more than 49 Australian dollars, twice Neptune's distance from the Sun. In addition, the orbit of Pluto is inclined at some point to the orbits of important planets in our close group of planets. This tendency not only increases the complexity of this circle, but also plays an important role in cooperation with other celestial bodies, especially Neptune. When Pluto meets Neptune, their gravitational forces interact over time and regulate their direction. The versatile dance between Pluto and Neptune highlights the dynamic nature of our close planetary group. Although Pluto was once thought to be a solitary traveler on its periphery, its close encounters with Neptune highlight the interconnectedness of the celestial bodies, with each exerting gravitational forces that shape the paths of the others. In recent years, advances in observational technology have allowed cosmologists to track Pluto's motion with extraordinary precision. This led to a better understanding of its orbit and its likely consequences for the stability of the outer close group of planets. Although the probability of a direct collision between Pluto and Neptune remains low, the possibility cannot be completely eliminated, which is why the astronomical community continues to monitor and investigate. Despite its modest size and remote location, Pluto attracts the attention and interest of scientists and fans. The question arises, why was there no accident between Pluto and Neptune? The answer is the gravitational pull of different planets. Stargazers began to focus on Pluto's path soon after observing it and were confused by its course. Unlike most planets, which stay in the same plane or ecliptic plane as they orbit the Sun, Pluto is distinguished by an uncertain point and an oval circle. The mystery increased when they discovered the path of Pluto crossing the path of Neptune. Despite these complexities, Pluto's ring remains stable and shows the complex mechanics of the cosmos. Learning how three divine bodies like Pluto, Neptune, and the Sun move and work together in gravity is a great challenge. It's like trying to predict where they're going to go based on where they start and how they're drawn to each other. For Pluto, this challenge shows how its path, Neptune's path, and the Sun's pull work together. Terms like simulation, binocular libration, and VSOP oscillation help researchers solve this huge puzzle. The simulation is crucial to keep the planets in their orbits. When Pluto crosses Neptune's path, it is at least 90 degrees away, preventing them from falling. Scope clearance ensures that when Pluto approaches Neptune or the other giant planets, it is clearly in their path, reducing the chance of a collision. Named after scientists von Zappel, Steves, and Saplin, the VSOP oscillation explains why Pluto's ring appears abnormal but remains the same for long periods of time. Despite the mess of the room, some patterns and rules keep things organized. These guidelines keep Pluto's orbit stable and prevent it from colliding with Neptune or changing its path. Pluto is a good example of orbital chaos, showing how the path of a celestial body is very sensitive to its origin. Even small changes in its state or speed can destroy this circle over a long period of time. Scientists use computer simulations to understand how Pluto moves through space. These simulations use complex mathematics to reproduce how Pluto interacts with other objects in space, such as Neptune. By adjusting these simulations, cosmologists can see how small changes can alter Pluto's path. In the late 1990s, these simulations discovered something interesting about Pluto's orbit. Although there are things that should make it stable, the Pluto ring can still be eccentric. Just a small difference in where Pluto starts or how fast it moves can lead to huge changes over many years. But even with this disturbance, Pluto's ring remains stable for a very long time, like billions of years. This suggests that despite Pluto's seeming unruliness, its journey around the Sun follows a pattern. It is difficult to predict what will happen to planets with complex orbits like Pluto. This framework is so real that it is difficult to predict what will happen in the long run. Simulations help us learn what might happen, but they also show that we can't completely predict everything. These models require detailed starting points and reproduce complex interactions. Even a small mess can lead to completely unexpected results, making accurate predictions difficult. Figuring out Pluto's orbit is important, especially when considering whether it could collide with Neptune in the future. This information helps us better understand how our solar panel works. The circle of Pluto shows how seemingly delicate circles can adjust under the influence of gravity and how things move in space. Continuing to observe and study these phenomena is essential to expanding our knowledge of the universe and our place in it.
Imagine if Pluto and Neptune had an impact, an unpredictable event that would send shockwaves through our understanding of the nearby planetary group. Although we have made progress in our understanding of space, this possible scenario shows that we still have a long way to go. Studying the influence of giant planets on Pluto's path gives us important insights into how the entire group of planets near us works. This shows us that where each planet is and how it moves can change the path of other objects in space. Despite the fact that space is curved, some leading scientists have suggested that Pluto could collide with Neptune. This concern makes them wonder why this could happen, even though it seems unlikely. Well-known space explorer Neil deGrasse Tyson has some interesting thoughts about Pluto. He believes that renaming Pluto from a dwarf planet to an Earth-like giant planet is a step forward. He agrees that we usually learn something new about the motion of things in space. Tyson sees Pluto's anomalous path as a sign that we still don't know much. He finds the mysteries of space fascinating. He also knows that important events in space, such as the renaming of Pluto, arouse people's interest in space science. Tyson wants to help people understand the amazing and sometimes unusual things about how the cosmos works. He thinks it is important to discuss how spatial mechanics can surprise us. Tyson works with various scientists to warn people about the potential dangers of Pluto's strange path. After an extensive focus on Pluto, the fact that it may one day collide with Neptune makes him focus. He says this could cause serious problems for our entire group of planets. An accident between Pluto and Neptune would be a rare and serious event. This would release a lot of energy and could tear Pluto apart. Pieces of the crash can fly around space and hit other planets and moons. Neptune also feels the influence and changes its movement. Renowned theoretical physicist Michio Kaku, known for his contributions to string theory and scientific communication, offers an interesting perspective on space exploration. He hypothesizes that the future of space travel and the connections between celestial mechanics and theoretical physics can be understood by studying the ring-like properties of Pluto. Kaku sees Pluto's ring as a window into the future of space exploration. By understanding the complex gravitational interactions and orbital dynamics of celestial bodies like Pluto, we can improve future space missions, help navigate the solar system more safely, anticipate potential risks, and plan missions to the far reaches of our cosmic neighborhood. Kaku emphasizes that the patterns obtained from Pluto's ring can also be applied to the study of other celestial bodies, providing a roadmap for interpreting distant universes. He often emphasizes the deep connection between celestial mechanics and theoretical physics, pointing out that planetary movements and interactions, such as the gravitational dance between Pluto and Neptune, are based on fundamental principles of physics. Kaku's work in theoretical physics, especially string theory, aims to dismantle these principles at their core.